Hello dear friends, welcome to Gate Academy Global. So before starting today's lecture, I would like to take the feedback or the concurrence regarding the quality of video as well as audio. Hello, video as well as audio. Is it perfect or not? Just wanted to know whether the quality of audio as well as video, if it is perfect, just write perfect over the live chat and then we are ready to go. Anyways, the agenda behind the series of the engineering mathematics we have been running since last 4 days must be known to all of us. We have started the each and everything from the engineering mathematics from the very basics of the very scratch. At very first class, I was discussing about the logarithmic function, and when we saw how the logarithmic function would look like over the xy plane. Once we were done with the logarithmic function, in last 3 days we were discussing about the straight line over the 2D plane, and even we have taken around 7 to 8 well-designed problem based on the concept of the 2D straight line. And more or less I was discussing about the tangent over the different structures. Even few of the questions were taken based on the concept when the tangent were drawn over the upper facing parabola. Even one question were taken where the tangent were drawn over the circle. So probably what I would expect that the each and individual student would have a fair amount of idea what they have been discussing about, what we have been discussing about. Anyways, the student who have been new for this series of the engineering mathematics, or they have been coming first time over my lecture, let me explain a bit what was my basic motive. We have been studying the engineering mathematics from very basics, and yes, I have been discussing about the basic curve since 4 days, and even the agenda behind today's video is also to discuss about the basic curve. And in today's lecture, basically I would be discussing around the basic trigonometric curve. Yes. So just wanted to know from each one of you the quality of audio and video. If it is perfect, just write perfect over the live chat. So without getting delayed, let me straight away hop into the working board. So each one of us should be writing. The agenda behind today's video has been the trigonometric functions, and even we will be talking about the trigonometric curves. Trigonometric curves. Trigonometric curves. Yes, till this point probably no voice. Hello. Your voice is audible or not? Hello. Yeah, probably voice must be coming, no? Tell me. Yeah, voice must be audible, no? Yes. Voice is coming, no problem, voice is coming. Yes. So my agenda has been the trigonometric function as well as trigonometric curves. Anyways, before going into discuss about trigonometric functions or the trigonometric curve, let me briefly discuss about the relationship between degrees and radians. I know many of the students used to have one doubt, sir, in which type of mathematical expression or the equation we had to go ahead with the radians, and in which type of the mathematical equations we can stick to degrees. And even they do not exactly know from where the concept of the radians have come into the picture. So before going into the detailed analysis of the trigonometric functions and trigonometric curves, I am going to initiate my today's video from the relationship between the degrees as well as radians. To understand this thing in a better way, what I am going to do over here, at very beginning I am going to draw a xy plane. Let's take, it has been a vertical axis, it has been a horizontal axis. The horizontal axis has been named as x-axis, vertical axis has been named as y-axis. And I have taken a circle which has been centered along the origin. For the time being, I have taken a circle which has been the center along the 0 or origin. With the help of two line segment, we have extended an angle at a point O. Let's take those two line segment had been This has been the first line segment which has been initiated from the origin and end up to a certain point over the circle. And similarly, we had another line segment which started from the origin and land up towards a certain point over the circle. And let's take this angle has been subtended as theta. The point had been A, origin stands for O, and this point goes C. So what I am saying, we had the two line segment OC and OA. They have been subtending the angle of theta at the point O. So if you want to write theta in degrees, obviously easily you would be right, or you would be able to write the theta in degrees. But at least at this moment of time, we are not interested to write the theta in degrees. We want to convert the theta, or the interpretation of theta. The interpretation of theta in radians. So tell me, what is the definition of the radians? I want the input from each one of you. The student who have been available for the live chat, they must be telling what is the formula for the angles in terms of radian, because here the angle has been written in terms of degrees. So if I wanted to convert the theta in terms of radians, which formula I should be using? Tell me. The formula what I use, theta in radians is equals to of arc length divided by the corresponding radius. Each one of us should be writing it. So if you want to calculate the theta in radius, the formula what we use is used to be arc length divided by the radius. For the time being, this 2 point A and C has been falling over a certain circle. Obviously, this radius of the circle must be known to me. That has been, let's take R. And similarly, even the arc length from A to C can be calculated. So once you calculate the ratio between the arc length, that has been AC, divided by the corresponding radius, whatever the result comes, that used to be the angle, and here we write radians. Now we'll try to expand this understanding even bit further. See what is happening, try to understand what I am. For the time being, if you had the two line segment, let's take the first line segment had been OD and another line segment had been OE. Let's take the first line segment had been OD and the another line segment had been OE. May I know how much angle has been subtended? Obviously, in terms of degrees, if we'll be talking about the angle subtension, the theta would be 90 degree. And if you interested finding the angle in terms of radian, so as per the definition, what would be the angle in radians? You had to talk about, or you had to discuss about the arc length. Obviously, it has to go from D to all the way E. May I know what would be its arc length? My dear friend, for the circle, the complete circumference, I repeat, for a circle, complete circumference used to be 2 pi into r. And you are just going to cover the quarter part of the 2 pi r. So here it becomes 2 pi r divided by 4. And at denominator, you have to take its corresponding radius. So what happens at last? The r and r is going to go out. And the result, what we get in our hand, is simply going to be pi divided by f2 radians. And yes, most of us must have been by-hearted this outcome, that the theta 90 degree is very same as pi by 2 radians. And one of the best thing regarding this complete calculation of the radius, in future, if you increase the radius of this circle, try to understand what I exactly wanted to say. If you have increased the radius of this circle, so what is happening? The same angle which has been theta is equals to 90 degree would be subtended a point from E to F. Yes, would be subtended from E to F. And once I would be taking the reference of theta is equals to 90 degree alone, tell me what would be the length of this arc? Now it would be 2 pi. You have got the new radius. Yes, you have got the new radius. Let's take that radius has been r dash. So here it's going to be r dash. Again, it has been quarter in nature. So obviously it's going to be 4. And towards the denominator side, you had to take its corresponding radius. Earlier, the corresponding radius was r. Now it has been changed to r dash. So what is happening over here? r dash is equals to of, again 2 divided by 4 would result pi divided by of 2 radians. What it indicates? It tries to indicate if the angle subtended by a certain conching has been precisely 90 degree, if you take its arc length, obviously taking a reference of any radius of circle, it could be r, even it could be r dash. So towards the numerator side you can take the arc length, towards denominator side you can take the radius. The arc length would be directly proportional to the radius, and now the radius and radius is going to go out, and whatever the component you get in your hand, that would be the equivalent angle in form of radians. In form of the radians. And may I know what's the best thing about the radians? The best thing is that it is not at all depending over the circle, because in future, even if you go forward, no, still angle is 90. If you go forward, still angle is 90. And even if you go forward, still you have been following over a larger radius of circle. This would become 2 pi r double dash divided by a 4, and it would become r double dash, r double dash, r double dash goes out. Still it remains pi by 2. Still it remains pi by 2. Could you understand what I am saying? So from here onwards you can understand in this way. If the angle has not been changed, the ratio between arc length and radius would always be constant, Let me take another situation where the theta has been precisely 180 degree. Theta has been precisely 180 degree, and my intention is to convert this angle from the degree to the radians. May I know what does that mean by the 180 degree? That means you have to take a line segment, all the way this line segment has to get opened, and it has to become just anti-parallel. What does that mean of it? The complete 180 degree expansion has been made. Now if we'll be talking about how much arc length we had to travel to start with a certain point to the anti-parallel point, obviously you had to take half of the circle. So the complete circumference of the radius used to be 2 pi r. Now you are just going to cover the half of it. So obviously the 2 would get divided at denominator, and again it would get divided with the r. So here the 2 r, and the result which has come into the picture has been pi. So probably till this point each and everything must be clear to all of us. So just let me take few number of conclusions. If you really want to convert any of the angles from degree to radians, you need not to worry at all. You just have to take the arc length over the circle divided by its corresponding radius, and this value would always be constant irrespective of the radius of the circle itself. Whether you are taking over here, whether you are taking over here, whether you are taking over here, everywhere the ratio between the arc length and radius would always be constant, and that has been the another way to refer the degree. Could you understand what I am saying? That has been another way to refer the degree, because as far as the degree, no, the degree has not been changed. Even it is keep expanding, the degree has not been changed. Even the ratio between the arc length and radius has not been changed, and hence we can say in future, instead writing the angle in degrees, even you can write in corresponding radians. Agreed till this point? Probably each and everything must be clear to all of us. Now let me focus a bit about the conversions, because I have seen many of the times you guys would have sort of doubt over here. So it has been clearly seen 180 degrees was very same as pi radians. That means 1 degree indicates pi divided by of 180 radians. So in future, if you are interested finding the value of 45 degree in radians, so simply what you can do, 45 can get multiplied towards left hand side as well as right hand side. Once it gets multiplied towards left hand side, it will become 45 degree, and here it becomes 45 into of pi divided by of 180, and the result would be in radians. Yes, 45 gets divided with the 180. 4 ja 45 is gonna be 180. So here it's simply gonna be 45 degree can be written as pi by 4 radians. See, such a beautiful mathematics is. And even if we'll be discussing about the pi, no, the value of pi is what? The value of pi is irrational. That means it would be 3.141, so on, so forth. Neither it would be repeating, neither it would be truncating. See, such a huge problem have come to a certain point pi where the value of pi itself was not clearly defined in terms of their decimal values. Yes, agreed what I am saying? Irrational number it is. Irrational number it is. Such a huge calculation were made. Even the angles were getting connected with the pi. For the time being, it looks like the pi would be a number which would be a very handy number to deal with. It's not that handy number to deal with. The pi has been a number which is nor truncating nor repeating. But till this point, probably each and everything must have been clear to all of us how the degree would get converted in a form of radians. Could you understand? So from here onwards, you can say the theta which has been in degrees, you had to convert into the radians. The theta has to get multiplied with pi at numerator and has to get divided with 180 at denominator. Whatever the result you get now, that would get convert the value of angle from degree to radians. Degree to radians. Yes, till this point probably each and everything must be clear to all of us. All of us. Now the next thing comes, many of the times we deal with the different kinds of the equations, and I have seen the student used to have one doubt, sir, should I be solving that problem taking the values of x as radian, or should I be taking x as degrees? Now I would like to ask from each one of you, what would be your choice? What would be your choice? Let me take few number of problems and I would try to frame few critical points from here onwards. Let's take the problem has been, which problem we can take like sine, let's take minus of sine square x is equals to 0, is equals to 0. If you really wants to solve this problem and wants to get the roots of this equation, obviously it has been a transcendental equation. So may I know, should I be calculating keeping the value of x as radian, or should I be calculating keeping the value of x as degrees, or can I do both? Can I do both? I can do both. See why? I can do both. Either you can smash this problem keeping x in degrees and even in radians. Why? Because x has already been followed inside the trigonometric ratios. The x has always been followed inside the trigonometric ratios. Like if you take another problem, like the problem has been, you had an equation, transcendental equation it is, sine x is equals to of x. Sine x is equals to of x. Now if I would like to ask the value of x which satisfies this equation, many of the students what they do you know that? Even you might be doing this, they used to keep the value of x in the degrees. My dear friends, if x is in degrees, obviously degrees gets operated over the trigonometric ratios which should lead a certain value, but here it can't be in degrees, no, because here you are getting absolute value. Here you are getting absolute value. Could you understand what I am saying? Here you are getting absolute value. So can I deal with the degrees as well as radians? No. Even in your calculator, probably in your calculator, the hard calculator is not allowed, but definitely you have a function solving buttons or the functions over this calculator. If you solve this problem sin x is equals to x by keeping the mode of operation in degrees, you will be getting the wrong answer. If you do this calculation over the radians, then only you will be getting the correct answer. Then only you will be getting the correct answer. So what would be your recommendation? What would be my recommendation? My recommendation would always be just go ahead with the radians. Just go ahead with the radians. Try to get the value of x whenever you have been dealing with a complex equation, obviously in radians. Once you're done with the radian, at any moment of time you can calculate in the form of degrees if you really want it. Yes, this formula can be easily applied over here. This formula can be easily applied over here. Could you understand what I am saying? You know, in terms of degrees, your radians, so you can just feed the data over here and easily you would be able to get the value in terms of radian. Anyways, just try to understand sine of x is equals to x, how it might be looking out. For that, what I am going to do over here, as I have been doing again and again, let me take a xy plane. Here goes the x-axis, here comes the y-axis, here comes the y-axis. See, sine x is equals to x, what it exactly indicates? It indicates the sine x is equals to of x is going to be a transcendental equation. Those all points of x would be the roots of this equation where sine of x exactly matches with x. Anyways, how the sine of x into sine of x would look like? The sine of x must be known to all of us. Yes, the sine of x would look something like this. Just a minute. Would something like this. Yes. At x is equals to of 0 radian, it would be crossing through 0, pi radian 0, 2 pi radian 0, 3 pi radian 0, minus pi radian 0, minus 2 pi radian 0. It has been sine of x. It has been sine of x. And now x has been a straight line, having a slope is equals to 1. And obviously as the constant value c had been 0, that means it would be crossing through the origin. So here goes the next. And it has been a straight line. It has been a straight line. It has been a straight line. How many number of solutions you are having? How many number of solutions you are having? So the point at which the sine of x becomes x or x becomes sine of x, or put together the intersection points between sine of x and x would be the possible solutions. May I know what are they? You have got the 3 number of possible solutions. Even the value of x or the slope of the x is decreased, no, you may have even more number of solutions. This sort of problem have come in case of numerical analysis, probably 4 years back in civil engineering. Could you understand what I am saying? So what I am saying, whenever you see the mathematics at any moment of mind, you must be able to relate that mathematics with the graphical approach. Until and unless you are not able to relate that mathematical equation with the graphical approach, you may not be able to actually understand what the problem stands for. Could you understand what I am saying? So the slope has been 1. If the slope would be reduced, let me take another curve. The slope is reduced, you can have even more number of solution. Let's take the slope has been reduced to 1 by 2. You can have another problem. The problem could be like sine of x is equals to of x divided by 2. How many number of solutions you will be having? Obviously, now you have the 2 number of solutions. 1, 2, 3. You can have the infinite many number of solution. If the slope becomes 0, obviously this straight line would be lying over the x-axis. How many solutions you will be having? All of the points where the sine of x crosses through the x-axis, they would all be the possible values. How many number of points you will be having as such? Obviously infinite number of points. What are the points you will be having? They would be plus minus n pi. Yes, plus minus n pi. Till this point, probably each and everything must be clear to all of us. So let me recall what exactly I wanted to communicate till this moment of mind. At very beginning, I had the relationship between the degrees and radians. When you have a certain angle in degrees, how will you convert in radians? And basically, I just wanted to focus from where the concept of the radian have come into the picture. The concept of the radian have come into the picture just by taking the ratio between the arc length divided by the radius over a circular periphery. And this has been a constant value. What does it mean of it? That means rather calculating the angles in degrees, even you can take the ratios between the arc length and the radius would also pretend the angle, obviously, but the methodology has been changed a bit, and that has been radius. Yes. And one of the best thing regarding the radian calculation, at numerator you had the arc length, at denominator you have the length. By default the length is getting smashed out. So whenever you calculate the angle in radians, it used to be a unitless quantity. That is the best thing regarding it. That's the best thing regarding it. It has to be a unitless quantity. That was not the case in case of degrees. No, that was not the case. And that's the best thing regarding the calculation of angle in radians. Tell me, sir, will you complete whole? After Makbul, I can at least assure one thing, my dear friend. All of the basics crux of the engineering mathematics at any cost we are going to cover. Once you are done with those crux of the basics part of the engineering mathematics, now you would be more than comfortable over the engineering mathematics. Exactly I cannot say till which moment of point I would be going ahead with the engineering mathematics, but at least I can ensure one thing: all of the basic part of the engineering mathematics, like all of the important curves, like straight line, parabola, circle, continuity, discontinuity, the part of the linear algebra, the point at which you guys find yourself difficult, we are going to cover those all. So you need not to have any doubt, at least till that moment of point. Till this point, each and everything is clear now? Yes, let me move forward. Now, at this moment of point, I would be discussing about trigonometric ratios. Trigonometric ratio. Each and everything is very important. I know many of the students would think, sir, why you are teaching trigonometric ratios? I know the trigonometric ratios. If you really think that you know the trigonometric ratios, just be patient for the next 5 minutes. You are going to learn ultra important thing. And whatever I am teaching over this series of the mathematics, no, they are solely based on the concept which are required for the engineering mathematics, specifically in GATE. Unnecessarily, I am not teaching anything. Otherwise, if I'll start teaching the trigonometric ratios or the straight line or the circle, which has been a part in the 11th or 12th, definitely you are going to learn so many garbage things, which is not at all important for the GATE. So whatever I am teaching, it is very crisp and clear that I have been intended you to prepare for the GATE examination. Trigonometric ratios. Anyways, before going into the detailed analysis of the trigonometric ratios, just have one thing in your mind. If you have been dealing with a right angle triangle, what does that mean by the right angle triangle? That means out of 3 interior angles, one angle would be precisely 90 degree and the remaining angles would be supplementary. That means their addition would be 90. As we know from the interior sum property of any of the triangle, the interior sum of any of triangle used to be 180 degree. Apart from 180, the 90 has already been dedicated towards right angle. So the remaining has to add on to 90. Yes. So what are the different arms or different sides you get whenever you deal with the right angle triangle? Obviously, the 3 different sides we used to deal with, among them one used to be base, one used to be perpendicular, and one used to be hypotenuse. And the name itself is quite self-explanatory. You are going to talk about their ratios. That means sometime you would be talking about the ratios between base and perpendicular. Sometime you would be talking about the ratios between perpendicular to hypotenuse. Sometime you would be talking about the ratios between base and hypotenuse. How many number of permutation you will be making? Why I am saying permutation? Because their order also makes sense. Sometime you might be having base by perpendicular. Sometime you might be having perpendicular to base. So out of 3 number of items, you are going to select the 2 number of items, and even their ordering is equally important. What used to be 3p2, that would be 3 factorial divided by of 3 minus of 2 factorial. And end of the day, we get the 6 different kinds of the trigonometric ratios. At very beginning, you may have base versus perpendicular. Secondly, you may have perpendicular versus base. Next, you may have perpendicular versus hypotenuse. Next, you may have hypotenuse versus perpendicular. And similarly, next you may have base versus hypotenuse. Next, you may have hypotenuse versus base. So how many trigonometric ratios we are going to extract by 3 different structures, 3 different sides of a right angle triangle? Obviously 6. What are they? They are gonna be sine, cosine, tangent, secant, cosecant and cotangent. Or simply I am going to write that sine, cos, tan. The inverse of the sine is gonna be cosine or cosec. Similarly, the inverse of the cos is gonna be sec, and similarly the inverse of the tan is gonna be cot. Could you understand till this point? Now the next thing comes in mind, sir, why their ratios are so important? Yes, this doubt should come in your mind. Why the ratios between base, perpendicular and hypotenuse has been so important? It has been important. If you really want to know, you can just have a bit idea about it. See what I am going to do over here. For the time being, I have taken a right angle triangle. Just a minute. I have taken a right angle triangle. Just a minute. I have taken a right angle triangle. Yes. Which makes the right angle at, let's take point B. Let's take point B. A, B, and here goes C. Here goes C. I repeat, just try to have an understanding from where the concept of the trigonometric ratios must have come into the picture. What I am saying, you have been dealing with the three sides. Obviously, as being a triangle, it would have the 3 number of vertices, it would have the 3 number of sides, it would have the 3 number of interior angle. Yes, it has been. And the 90 degree has been framed at a point B. And for the time being, if you take the reference of the angle A, that means the calculation of the trigonometric ratios has been taken. Taking the reference of A, this becomes perpendicular. Yes, the reference angle, the side front of reference angle becomes the perpendicular. This becomes a perpendicular. This becomes a hypotenuse, and this becomes a base. This becomes a perpendicular. It's a base and it's a hypotenuse. Yes. Now, one of the best thing regarding it, if you will be taking the ratios, like you can take the ratio between P versus B, you can take the ratio versus P versus H, you can take the ratio versus B versus H. Now, in future, what you are going to do over here, if you have extended this problem a bit, like C has been extended to a certain point, and even the B has been extended to a certain point, and still it has been framing the right angle. Let's take the point has been changed to C to C dash, and similarly B to B dash. Now the new base is gonna be AB dash, and similarly new perpendicular is gonna be B dash C dash, and similarly new hypotenuse is gonna be AC dash. I would like to ask one thing from each one of you. If I say BC divided by of AB, is it same as B dash C dash divided by of AB dash? What would be your answer? I repeat once again. If I say the ratio between BC versus of AB, would it be very same as B dash C dash divided by of AB dash? That's the first question which I would like to ask from you. Similarly, even you can take the reference of BC divided by of AC. Would it be very same as B dash C dash divided by of AC dash? Tell me. I would like to have the answer from each one of you, and I used to suggest again and again, my dear friends, whenever we used to take the classes, try to have the two-way communication such that you guys would also be able to connect with my each and individual concepts. What I am saying, their slopes, their ratios, would it be same or would it be different? They would be very same. And as they have been very same, from where this concept have come? This concept have come from the concept of similarity. Anyways, I am not going to discuss about the similarity, at least over this moment of point. But one thing is quite sure, yes, their ratios has been very same. What does it mean of it? That means if you are not changing the angle across A, either you take the ratio between base to hypotenuse to another base to another hypotenuse, keeping the same angle over here. Even you can take the ratios between perpendicular to hypotenuse, perpendicular to base, base to hypotenuse. All of them are going to be utterly same. How did I come to this point? Anyways, I am not going to discuss, at least because this two triangle has been what? Similar triangle. And once the two triangle follows their similarity, their ratios comes into the proportionality. I am not going to go in that detail. Could you understand what I am saying? That means in future, if you took the ratio between AB versus of AC, that would be very same as a AB dash versus of AC dash. Even in future, you can take the ratio between like BC BC versus of AC. So in future it would be same as BC dash divided by of AC dash, divided by of AC dash. So from here onwards, one of the very important term or very important concept do come into the picture. If the angle has not been changed at this moment of point, their ratios would not change. Ratios of what? Ratios of their three sides, perpendicular, base and hypotenuse. Their ratios are not going to change. How many number of ratios you can have? 6 number of ratios you can have. Yes, such a powerful tool it is. If you are not going to change the angle across this point, keep in mind the ratios of their sides are not going to change. Either it has been AB versus AC, it would be very same as a AB dash versus AC dash, because they have been made taking the same reference of the angle which has been theta, Just wanted to know, could you understand what exactly I wanted to say over here? Yes. So now such a powerful tool we have got in our hand. Rather discussing their ratios, the ratios are not at all going to change, no. Why don't we talk about individual, no, I'm not going to talk about the individual hypotenuse, base or perpendicular. I would just be focusing over their ratios, and the ratios remain same until and unless the theta is not getting changed. That's a different story together. If the theta would increase and decrease, definitely their ratios, the ratio of the earlier right angle triangle and the next right angle triangle would change in the picture. Yes, so let me move forward. And discuss about the different trigonometric ratios. At very beginning we deal with sine of A. Yes, if I deal with the sine of A, obviously it used to be the ratio between perpendicular to the hypotenuse, my dear friends. Perpendicular, if it has been at a point of A, so obviously the vertically opposite side would be BC. So towards it would be BC. Yes, and here you can write it over here, somewhere here. Yes, here it has been A, here it has been, let's take B, and here it has been C. It has been right angle triangle at the vertex of B, So here it becomes perpendicular divided by the hypotenuse, and that has been AC. Keep in mind, whenever we talk about the sine at any angle A, by default we used to take the ratio between perpendicular to the hypotenuse. In the same sequence, we can do tuck what it is. Let me move ahead. Cos of A, it's also called cosine of A, because many of the times I have seen just by little bit change of the way the things are expressed, I know many of the students used to fear a lot. Cosine of A, that is very same as cos of A, and that used to be base divided by of hypotenuse. If I take the reference of A, obviously the base had been AB divided by of AC. So similarly you can write for 10 of A, that would be tangent of A, that would be equals to of perpendicular, that has been BC divided by of base, and that has been AB. And now if you will take the reciprocal or inversion of sine of A, you would be leading with the cosec of A, here secant of A, that is nothing but sec of A, and here we lead cotangent of A, and that is nothing but cot of A. So till this point, probably each and everything must be clear to all of us. Yes. Now let me discuss about the curve of the individual trigonometric functions. At very beginning, let me start with the sinusoidal function. To better understand the sinusoidal function, let me take a circle. Over a xy plane, which has been centered along the origin and had the radius is equals to 1. Let's take, you had radius has been 1. Just a minute. Radius has been 1. If the radius has been 1, obviously it would be crossing through minus 1 comma 0, 0 comma of minus 1, 0 comma of plus 1, and here it should be passing through 1 comma of 0, 1 comma of 0. Now try to understand in this way. What used to be sine of A or sine of theta for the time being? Sine of theta has been the ratio between perpendicular divided by hypotenuse. I repeat, it has been the ratio between the perpendicular divided by hypotenuse. Now what I am going to do over here, I have subtended a line segment. Let's take which starts from O, goes till A, Then maybe it starts from O, goes till B, starts from O, goes till C, starts from O, goes till D, and similarly you can take this also. Let's take the point had been A, here it had been B, here it had been C, here it had been D, and here it had been E. And as far as the sine of theta is concerned, no, I am taking the angle theta, taking the reference of positive x-axis. Sine of theta, that used to be the ratio between perpendicular divided by of hypotenuse. You can see yourself from O to A the distance has been very same, O to B the distance has been very same, O to C distance has been very same, because those all points have been kept over the center, circle, and you have been measuring it from its center. That means in future if you apply a sine over this angle theta, what would be the worth? The worth would be perpendicular divided by of hypotenuse. The hypotenuse remains constant throughout the variation, whereas the perpendicular is continuously increasing. Probably each one of us would agree on this point. The perpendicular is continuously increasing. So as you are moving from B to C, the perpendicular got increased. As you moved from C to D, the perpendicular got increased. As you moved from D to E, the perpendicular got increased. Each one of us would agree on this. And if you will take the reference of A, the perpendicular had been 0. The perpendicular is nothing but the vertical displacement from the x-axis, and as the point itself was lying over the x-axis, definitely the vertical displacement from the x-axis is simply going to be 0. Here it would be increasing, even increasing. So I would like to ask one thing. If you calculate the sine of theta for this triangle, just a minute. Sine of theta for this triangle, if you calculate the sine of theta for this triangle, value of sine of theta, would it increase or would it decrease? Obviously it would increase, as the value of P is continuously increasing, whereas the H has been constant. Similarly, if you'll move towards the second quadrant, what is happening over here? Just try to understand in this way. I have taken the references of the older point. Let's take, we have gone to this point. It has been D dash, C dash, B dash. Again the same thing is happening. If you keep connect them, like, see what is happening. Could you understand or not? As you are going in this direction, now theta is keep increasing. Yes, theta is keep increasing, and as the theta is keep increasing till 90 degree, the perpendicular is keep increasing, whereas the hypotenuse was kept constant. Similarly, as you go beyond 90 degree, what's happening? The perpendicular is keep decreasing. And that too, worth of perpendicular has been still positive. But once you come down, let me take another reference. Once you come down, let me go downside. Let me do all sort of analysis. See what is happening? Once you come down, or if you go beyond 180 degree, you will take the reference of this, then you will take the reference of this, then you will take the reference of this. What is happening over here? Obviously, the magnitude of the perpendicular is keep increasing, but the perpendicular had been negative. So as far as the ratio between perpendicular to the hypotenuse is concerned, perpendicular had been positive as it has been above the x-axis. So the ratio between perpendicular to the hypotenuse would remain positive. That is why we say the sine of theta remains positive in first as well as second quadrant. And once you come into the third and fourth quadrant, keep in mind the perpendicular, as we had to go down, becomes negative, and hence the perpendicular becomes negative. So by default, the sine of theta would become negative, because the hypotenuse cannot be negative at any case. How the hypotenuse is being calculated? Hypotenuse is equals to of root over of perpendicular square plus of base square. That means the hypotenuse is precisely going to be a positive value. So the P, or the sine of P, is going to be decided whether the sine of theta is going to be positive or negative. So here it's going to be negative, and here it's going to be positive. Here it's going to be positive. Till this point, probably each and everything must be clear to all of us. Now, for the better understanding, what I am going to do, just try to understand what I am going to do over here. You'll really like this. Let me draw sine of x over here. See how will you draw it? How will you draw it? Let me take, yes. See, just try to understand how it has been. At theta is equals to 0, you yourself would be able to understand the perpendicular had been 0, so the magnitude of sine of theta is going to be 0. Now, at theta is equals to, let's take theta 1, the perpendicular to the hypotenuse would be increased a bit. And similarly at theta 2, obviously perpendicular is even larger, the hypotenuse had been same, so the value of sine of theta would increase, and the maximum value of sine of theta would be at theta is equals to 90 degree, where the perpendicular is very same as hypotenuse, because now the perpendicular has been lying over the straight line, or has been lying over the circle itself. So if you really want to draw the curve, just by taking the reference of horizontal line, you can easily draw the sinusoidal curve. How it would be? Sinusoidal curve would be like this. Yes. Sinusoidal curve would be like this, where the upper peak would go to the 1. Yes, it was 0, 1, no? The upper peak would go to the 1, and lower peak would come to the minus 1. Agreed? And this sort of methodology, or this sort of understanding, is very much required when we specifically deal with the electrical engineering. But anyways, you can understand this thing into the better way, that even with the help of circle, easily you would be able to draw the sinusoidal signal. So wanted to ask from each one of you, till this point, each and everything got cleared or not? Just by taking a reference of a circle having a radius is equals to 1 centered along the origin, I could draw the sinusoidal signal. You yourself would be able to see when the theta was keep increasing from 0 to 90 degree, or 0 to pi by 2. Yes, even sine of theta was keep increasing, and it was positive. And as the angle was moving from theta is equals to pi by 2 towards the pi, keep in mind the perpendicular was keep decreasing, but still the perpendicular was positive. That is why still it is decreasing, but had been towards the upside of the x-axis, had been positive. Similarly, if you go down towards this side, what is happening here? What is happening over here? The perpendicular is keep increasing, but they have been negative in nature. The perpendicular is keep increasing, so magnitude of the sine of theta would be keep increasing, but it would be negative. That is why this is nothing but the x-axis, no? That is why now the curve have come towards downside. When you will be having the least value or the highest magnitude, obviously it would be at x is equals to 3 pi by 2. There the magnitude got minus 1. Here it became 3 pi by 2. Here it became pi, and here it became 2 pi. And this has been the curve for sine of x. Till this point, each and everything must be clear to all of us. Now in the same sequence, it's the right time to discuss about cos of x. If you know how the sine of x has been drawn, precisely you can draw even cos of x. Cos of x can be written as sine of x plus of 90 degree. That means at very beginning you can draw the sine of x, and then you can shift the complete curve towards the left hand side by pi by 2. So whatever the curve you get afterwards, that's gonna be the cos of pi by 2 itself. So how the curve you used to have? So if you'll be focusing over the sine of x, the curve used to be sort of this. Yes, no? The curve used to be sort of this. And now what we are going to do over here, the complete curve has to get shifted by the pi by 2. Here goes pi by 2. Here goes pi by 2. The complete curve has to get shifted by pi by 2. Either you can shift the complete curve towards left hand side, or you can shift this yx towards right hand side. So I am interested to shift the y axis itself. Y axis itself. So here it goes somewhere here. Yes. And let me do one thing. Let me rub this out, this portion. And that had been the curve of sine of x. That had been the curve of sine of x. Yes. And if you'll be talking about this maximum value and the minimum value, nothing had changed. Nothing had changed. Still the maximum value would go to the +1 and minimum value would go to the -1. Let me take the reference also. So here it goes like this, and here it goes like this. Yes. It goes to the +1 and then -1. +1 to the -1. At least while analyzing the sine of x curve as well as cos of x curve, the few of the important concept would have been come out. What are they? The sine of x and cos of x are the oscillating signal with the constant frequency and magnitude. If you want to write somewhere, you can write it. Write down. The sinusoidal and cosinusoidal signal. Anyways, I don't say cosinusoidal signal additionally, because in future, if you have any of the signal which follows this format, whatever the shift that signal may have, still I call it sinusoidal signal. So nobody should have the additional understanding of the cosinusoidal signal, because the cosinusoidal signal can be easily retrieved or removed from any time with the help of Phillips. Agreed? So few of the important points regarding the sinusoidal signal. Even the cosinusoidal signal would also be the part of it. First, it is complete smooth curve. That means at any moment of time, if you check the continuity of the signal, this signal is completely continuous. Not only that, if you want to draw the tangent at any moment of point, tangent, what does that mean by the tangent? That has already been dealt in past 2 classes. Tangent, in Hindi it's called Sparsrekha. You would be able to draw the tangent at any moment of time uniquely. So sine is a perfect differentiable curve at any point of x. And as the sinusoidal or cosinusoidal signal has been differentiable throughout the range of x, by default it would be continuous, and by default their limit would exist. Yes. Till this point, each and everything must be clear to all of us. Now I would like to take the reference of another important curve, which has been a very important curve, and I know many of the students are going to suffer a lot while drawing this. Again, let me take the reference of xy plane. Here goes the horizontal axis, here comes the vertical axis. Let's take it has been a horizontal axis which has been marked as x, and similarly let's take it has been vertical axis which has been marked as y. Tell me how the tan of x would be drawn. If you really want to know how the tan of x would look like, better to understand this curve. The tan of x has been the ratio of perpendicular to the base. See, at very beginning, when the theta was 0, perpendicular was 0 and the base was same as was a hypotenuse. As the perpendicular was 0 and the base is same as a hypotenuse, their ratio would become 0, and that is why tan of theta is being taken as, or tan of 0 is being taken as 0. And as the theta is increasing, do you know what is happening? The base is decreasing and perpendicular is increasing. What is happening? the base is decreasing and perpendicular is increasing. That means at the rapid speed, the tan of theta is increasing. Tan of theta is increasing. Similarly, if you go over here, obviously the base has been even shrunk and now the perpendicular had been increased. And once you go at theta is equals to 90 degree, what is happening over here? What is happening over here? See, the base has been shrunk to 0 and now perpendicular have gone to the hypotenuse. So at tan is equals to of 90 degree. What I repeat, tan is equals to of 90 degree. What is going to be the ratio between perpendicular to base? What is gonna be the ratio between perpendicular to base? This is the point I have seen many of the students used to have doubt. The people say just infinity. It's not the case. It's not the case. I would be bifurcating in two part. Either it's a case of x is equals to of pi by 2 minus, or whether it is case of pi by 2 plus. If you take the reference of pi by 2 minus, that means it's before 90 degree. If it is before 90 degree, keep in mind, once you draw the projection of this line over the x-axis, you will be getting a very minute or very small base. That base would be positive or negative? That base would be positive. That means perpendicular is very same as hypotenuse, which always be positive, and towards denominator side you have got 0 plus. So the ratio between a finite value with the 0 plus would always be infinity plus or plus infinity. Similarly, if you go beyond pi by 2 plus, let's take the point have come somewhere here, and if you'll be drawing over here, so may I know what would be the base? The base would be utterly small. Again, you will be taking the ratio between h plus, but here it would be 0 minus. Why? Because now you have gone towards the negative value of x. As the value of x has been negative, obviously the base would be negative. Anyways, if we'll be talking about the ratios, in first quadrant, tan would be positive, tan of theta would be positive. In second quadrant, as the perpendicular is positive, but the base is negative, it would become negative. In third quadrant, perpendicular and base both have been negative, so it would be positive, and here it would become negative once again. Could you understand till this moment of point? Yes? Yes? Could you understand till this moment of point? See, the concept of plus infinity and minus infinity. Could you understand this thing in your mind or not? Obviously, you should have a clear-cut idea about it. So let me draw how the curve of tan of x would look like. Let me see how the curve would look like. Just a minute. Let me take few number of blocks such that I would be able to draw the things into the very proper way. Yes. Let's take, it has been the x-axis, it has been 0 radian, it has been pi by 2 radian, it has been pi radian, it has been 3 pi by 2 radian, it has been 2 pi radian. So in between 0 to pi by 2, the tan was continuously increasing, and at pi by 2 minus, it reaches to the plus infinity. How would be the curve? Obviously, sir, the curve is going to be sort of this. Like this. It is going towards plus infinity, obviously at minus pi by 2. And at plus pi by 2, it would start from minus infinity and the magnitude would be continuously decreasing. And at pi, the magnitude would become 0. And at 3 by pi by 2, you can see yourself. This would be the curve. If you really wants to know how did it happen, see, in between 0 to pi by 2, the perpendicular is going to be positive, base is going to be positive, definitely the worth is going to be positive. In between pi to pi by 2, the perpendicular is going to be positive, the base is going to be negative. That is why the ratio has been negative towards the negative value of y. Similarly, in between pi to 3 pi by 2, what's happening over here? The perpendicular and base both have been negative, obviously. That is why it has been positive. In between 3 pi by 2 to 2 pi, what is happening over here? Obviously, the curve have been negative over here. And specifically, if you will be discussing at pi by 2, perpendicular would become hypotenuse and base would become 0. So the people say, why don't we write infinity itself? No, you should not be writing it infinity itself, because 0 even can have its sign, could be 0 minus or could be 0 plus. When it should be 0 minus, when it goes towards the left hand side of the x-axis, when it's gonna be 0 plus, when it goes towards the right hand side of the x-axis, when it would be towards right hand side, obviously at pi by 2. You can see yourself, just a minute, where at pi by 2 minus, and towards the pi by 2 plus it would become 0. Similarly, if you'll take the analysis over this point, see what is happening over here. At pi minus, it's gonna be 0. And now if you'll take the reference of 3 pi by 2, see. At 3 pi by 2 minus, perpendicular as well as base both has been negative, and once you'll take their ratio, it would be positive. And once you'll go towards 3 pi by 2 plus, the base have become positive, which is 0 plus, and whereas perpendicular is still a negative value. Their ratios would be this. Agreed? Now I don't find that any one of us would have any sort of doubt now. No, nobody means nobody. Yes, sir. How many number of students are live over this session? 4 number of concurrent viewers we have. Just wanted to ask from each one of you whether you are liking this way of communication or not. Because many of the times I have seen the student used to say, sir, we are getting bored, but I don't feel so. Because I have said earlier that we are going to learn each and everything from the scratch, and that is why we are going to learn this. Now one more important thing. If you will be talking about the period of sinusoidal signal, obviously including the co-sinusoidal signal, that has been 2 pi. You yourself would be able to understand. Yes, after 2 pi, the same signal have start getting repeated. But if we'll be discussing precisely about 10 of x, may I know what used to be the period of the 10 of x? It has been pi now. You yourself would be able to understand. They have start getting repeated. So the period of 10 of x is simply gonna be pi. So far the problem related to this concept has not been seen in mathematics, but in future you would be able to experience at least one problem from this concept. Yes, my dear friends. And now from here also you can calculate many of the things like you can take the reference of 45 degree. You can take the reference of many of the things like here it could be plus of 1, here it could be minus of 1. It would be pi by 4, so on and so forth. Varsa Snehi, at least I have communicated this thing probably 2 or 3 more times. What I am saying, I am going to cover all of the basic part of the engineering mathematics such that you will have the very strong fundamental of very strong basics of the engineering mathematics. I am exactly cannot say whether I am going to complete the complete engineering mathematics or not, but at least one thing is quite sure. The basic fundamental of the engineering mathematics would be utterly clear once you sit in my each and individual videos. And probably I would try to cover 2 to 3 important topics for your syllabus of GATE also. Now tell me, how will you draw cot of x? Once you're done with the cot of x, my complete understanding is done. See, 10 90 plus of theta is equals to of minus of cot theta. That means what you had to do? You had to shift the complete curve towards the left hand side. That means this y-axis would come at this point. This y-axis would come to this point. So let me do one thing. What should I be doing over here? Either I can shift this complete signal towards left hand side, or either I can bring this y-axis to this point. So I am doing the same. Let me do one thing. Yes. May I know which curve it is? this curve has been minus of cot of x, but you want to draw cot of x, what you had to do? You had to multiply with the minus sign. Yes, 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 yes. You had to multiply with the minus sign. If you really wants to multiply with the minus sign, this complete curve gets flipped. Like earlier it was this, no? Now it will become this. So this curve has to get flipped. This curve has to get flipped. So here it goes. Here it goes. Just a minute. Like this. Like this. Like this. Like this. Now you can do one thing. You can rub this out. Which one? This blue curve. You can rub this out. Yes. Now the pink curve, what you are getting now? Pink curve, what you are getting? That has been the curve for cot of x. Cot of x. Now probably you would be able to visualize how the cot of x is being drawn. Cot of x is being drawn. So my agenda was to discuss about the three important curves: sine of x, cos of x, cot of x, tan of x. Even it would be your homework to draw the sec of x as well as cosec of x. And in tomorrow's class, what we are going to do, we are going to take few number of numericals over the trigonometric functions as well as trigonometric curve, as I have been doing so far. Whatever the topic I take from the basic, even we used to take the 4 or 5 number of problems based on that important basic topic. So in the same fundamental or in the same league, we are going to take few number of problems in tomorrow's class. Till then, bye bye, take care, and yes, keep reading, keep reading. We'll meet tomorrow precisely at 9 p.m. Thank you. Bye bye.